Simultaneous equations. Simultaneous equations are two sets of linear equations with two different unknown variables. To solve them, you must first find two unknown variables in the equation. The general form of linear equations is ax plus bx equals c. We must solve for a and b. This gets more difficult when there are two sets of linear equations. For example, for the linear equation for x plus 2y equals 6, we need to solve for x and y. If we were to implement a second equation of 3x plus 6y equals to 9, solving for x and y becomes a bit more challenging. One of the methods used to solve linear equations is elimination. This method eliminates one of the unknown variables, leaving you with a linear equation with only one more unknown variable, making it easier to solve. Elimination is either adding or subtracting one of the two unknown variables from one another to remove it from the equation. Once you have found the value for one variable, you can substitute it into one of the two original linear equations to solve for the other unknown variable. For example, these two linear equations have a value that can be eliminated. 2y and negative 2y cancel each other out when added. From here, we can simply add the two linear equations together to obtain a new equation and hence remove the unknown value of y. With our new equation, we can solve for x. Using this value, which is 5, that we found for x, we can substitute it into one of the original linear equations, either 3x plus 2y equals 11 or 2x minus 2y equals 14. For example, by substituting x equals 5 into the original equation, 2x minus 2y equals 14, we can solve the equation to find the value of y, which is negative 2. By rearranging to make y the subject, we can then solve for y. The answer, or two final values we find are y equals negative 2 and x equals 5. Another method is solving using graphs. To solve simultaneous equations using graphs, we substitute 0 for each variable to find the value of one another. We substitute x to equal 0 to find the value of the y-intercept, and we substitute y to equal 0 to find the value of the x-intercept. For example, for the linear equation 2x minus 4y equals 18, we would substitute x to equal 0 to find the final value of y, leaving us with the equation 2 times 0 minus 4y equals 18. Once we find the graphs of the x and the y, we can sketch the linear equation on the graph. And once we find the value of linear equations, the point of intersection will be our x and y values. For example, the first step to graph these two linear equations is to graph them individually. We will start with the equation in red for Romeo. To graph this equation, we must first find the y-intercept and x-intercept. To find the y-intercept, we substitute x to equal 0. Since 4 times 0 is equal to 0, we are left with the equation 3y equals 14, which we can rearrange to get this y-intercept of 14 over 3, or 4 and 2/3. Now we must find the value of the x-intercept. We must substitute the value of y to equal 0. This results in 3 multiplying by 3 to equal 0. By doing so, we obtain the equation 4x equals to 14. Now we can rearrange the formula and obtain the value of the x-intercept, which is 3.5. Since we have found the intercepts for the first equation, we must do the same for the second. For this green equation, we must substitute the value of x to equal 0 once again to find the value of the y-intercept. Once we have done so, we obtain the value of the y-intercept, which is negative 4.5. We do the same for the x-intercept and substitute y to equal 0, giving us the value of the x-intercept, which is 9. Green is the color of my curry beef, which I highly enjoy. Since we have obtained the values of the x and y-intercepts for both equations, we can now graph the equations and find the intercept point. If you remember, the values for the red equation were y equals 4 and 2/3 and x equals 3.5. And for the green equation, y equals negative 4.5 and x equals to 9. We now place the values we obtained onto the graph. We start with the red equation and place the y-intercept of 4 and 2/3 onto the graph. Then we will place the x-intercept of 3.5 onto the graph. After we obtain both points on the graph, we draw a line through them. As you can see here, this intercept point is 4 and 2/3 and this intercept point is 3.5. Since we have graphed the first equation, we will now graph the second. For the green equation, the intercepts are y equals -4.5 and x equals to 9. We will do the same. Place the point of the y and x intercept onto the graph, then draw a line through it. As you can see here, the two equations intersect at the point 5 and -2. We can conclude that 5 is the value of x and -2 is the value of y in the equation.
Hello everybody, my name is Zorawa Singh Thappar and I will be teaching you how to do matrices. What is a matrix? A matrix is a suitable way of representing a particular collection of numbers, which is usually found within the context of simultaneous equations. As our example shows, this is a 2 by 2 matrix, meaning it has 2 rows and 2 columns. Now adding and subtracting matrices is pretty straightforward as it shows. 6 plus 21 equals 27, 3 plus 1 equals 4, 7 plus 69 equals 76, 2 plus 5 equals 7. And the same thing goes on with subtracting. 6 take 1 is equal to 5, 3 take 1 is equal to 2, 17 take 9 is equal to 8, and 12 take 5 is equal to 7. Multiplying matrices. As our example shows, in this case we have the 3 on the outside, meaning that you times everything inside, which equals to 6, 21, 12 and 27. Now we move on to inverse matrix. This is very simple because you have your standard equation A, B, C, D and you have your determinant, and what you do is you flip it and put negative signs. Now you're probably asking, where do you flip it and put negative signs? Where A and D are switched to D and A, and negative B and negative C. Those are your new equations. And as our example shows, you have 4, 7, 2, 6 to the power of -1 switched. Negative signs. This is substituted in 1 by 10, 6, -6, -2, 4, and what you're left with is 0.6, -0.7, -0.2 and 0.4. But don't forget, we still have to find the entire value. So what we do is x1, x2 is equal to 118.4, 135.2 times -9, 8.75, 8 and -7.5. Now if you work that out, your answer will equal to 16 and 22. Now last but not least, we are left with simultaneous equations using matrices. Now in this case, what you do is, let's take the scenario of a family. The kids' bus fee is $3, adult is 3.5, and the total is $118. Then you have on a train ride $3.20 for a child and $3.60 for a adult. What do? You substitute the AD take BC, which we know is our determinant, with these numbers, and you inverse it. So 3.6, 3, those are flipped, and those are given negative signs. Our total is this. Now everybody, we move on to simultaneous equations using substitution. You may ask, what is that? That is when one of the two variables are substituted into the equation, producing a third equation with one variable. As our example A shows, y is equal to 2x take 1 and 3x plus 4y is equal to 29. This is very easy because y is equal to 2x take 1. So in this equation right here, you can substitute the y into the equation and it gives you 3x plus 4 in brackets 2x take 1 is equal to 29. This is further simplified to 11x is equal to 33, and once divided, x is equal to 3. Then you substitute the x into the first equation and you get 6 take 1, which is equal to 5. So y is equal to 5. And our second example, which is a little harder, is y is equal to 5x take 8 and y is equal to negative 3x plus 16. So you may ask, what do we do? Since both of them are equal to y, you equate them, meaning that it is put in this form. 5x take 8 is equal to negative 3x plus 16. That is further simplified to 8x plus 24. As we know, we take the negative 8 to this side and our negative 3 to this side, both becoming positive. So it's 8x is equal to 24. Once divided is equal to 3. Then you substitute the 3 into this first equation or this equation, whatever you prefer, and you will get the answer of 7.